Since the creation of man, our bodies have been functioning in a miraculous way without us even having to lift a finger, all thanks to the little superheroes within us. When the hypothalamus gets negative feedback, it sends hormones to the anterior pituitary, which then sends out thyroid-stimulating hormone to its target tissue, the thyroid gland. The thyroid gland serves as the headquarters for thyroxine and triiodothyronine, also known as T3 and T4. These two superheroes are born and raised in the gland. The follicular cells produce these amazing beings, and the colloid houses them until they are activated by the command in the anterior pituitary. The thyroid hormones T3 and T4 are not very different in their molecular structure, other than T4 having an extra iodide ion. The two are practically twins and do everything together. Since T3 and T4 are nonpolar, they are hydrophobic, meaning water is their kryptonite and they fear it. But being nonpolar does not set them back, and it is not a weakness in any way. They use it as a superpower to go straight through the cell membrane, like Kitty Pryde in X-Men. Since command has received negative feedback, the superheroes are often an adventure. They hitch a ride on carrier proteins, just like their great pals, the steroid hormones. They travel through the bloodstream until they reach the cell in need. They finally reach the cell. Now what? There's no door to get in. Well, they're nonpolar, so they can just go straight through the cell membrane. It's a bit of a tight squeeze, but they finally make it through the lipid bilayer of the cell. Now, their next step is to find the intracellular receptor, the inside man, that's going to help them find their targets, the nucleus and the mitochondria. Once in the nucleus, the thyroid hormone binds to the hormone response elements on DNA. This causes transcription of RNA. Once this is complete, the RNA leaves the nucleus and goes to the ribosome for translation. This is where enzymes and proteins involved in glycolysis and ATP production are made. The other thyroid hormone binds to the intracellular receptor on the mitochondria. This is also known as the powerhouse of the cell. This action produces ATP, which is energy for the cell. The enzymes produced in the nucleus multiply the rate of glycolysis, creating even more energy. Thanks to our superheroes, with the production of so much ATP, the cell is now able to use an sodium-potassium ATPase pump. This allows sodium ions to leave the cell and potassium ions to enter the cell. Our superheroes have completed their mission. Not only did they increase the metabolic rate of the cell, but they also produced a calorigenic effect. From the ATP in the mitochondria and glycolysis, the cells consume more energy, creating heat. And somewhere along the way, our T4 became a T3. Now that's a mystery for next time.